YouTube channel, SMA Online Physics. We have been discussing about reflection of light by spherical mirrors. If you haven't watched my previous videos, do watch them so that you can be very clear in this session. Today in this session, we are going to do, problem solving, right? We are going to do some very good, beautiful problems, and I'm going to teach you how to solve problems easily, right? Related with spherical mirrors. All right, here we go. Question number 1. An object of size 15 centimeters is placed in front of a spherical mirror of radius of curvature 40 centimeters. An image is obtained on a screen at a distance of 60 centimeters from its pole. Calculate the distance at which the object should be placed from the pole of the mirror. Also find the size, nature of the image and the magnification achieved. So the solution, my dear students, for this question number 1 is an easy problem to begin with. An object of size 15 centimeters. So mind the question, the mirror's name is not exactly mentioned here. Alright, it says is a spherical mirror of radius of curvature 40 centimeters. But an image is obtained on a screen here. So if the image is obtained on a screen, then it is a real image. And if the image is real, we know from our previous discussions, the mirror has to be a concave mirror. Here we go. So we will write given for concave mirror. Concave mirrors can form both real as well as virtual images. So an object of size is given to you, h equals 15 centimeters. So h equals 15 centimeters is placed in front of the spherical mirror. Radius of curvature is 40 centimeters. Alright, and the image distance, the image is obtained on a screen which is placed at a distance of 60 centimeters. Alright, okay, calculate the distance at which the object should be placed, size of the image and the nature of the image formed. So let's get on to it. You need to find where the object is to be placed, height of the image, the nature, and even if you want you can find the magnification also. This is what the question looks like. Okay, now here's a very simple and very important point, that you need to draw a small concave mirror for your clarity of sign conventions. You should be 100% sure about what kind of signs to be placed. Now since you're dealing with concave mirror, from here you can see that height of the object, everyone knows it, should be positive. Radius of curvature, now you can see the distance that is lying to the left hand side. So it should be negative, so minus here. So therefore focal length should be equal to r by 2, that gives me minus 20 centimeters. I think it's very clear, negative sign. Image, a real image is always formed to the left hand side, so it should be also given with negative sign. I think sign conventions are very clear. Now we can proceed through the formula, the mirror formula. Okay, once again you can pause here if you're not sure about the sign conventions and just follow the link above to watch the video on sign conventions. Okay, so let me start with the mirror formula. 1 by v plus 1 by u equals 1 by f, and here I wanted u to be calculated out. So you can do this simple mathematics very easily. After you get the signs, there is no trouble at all. So 1 by f is there, minus 20, minus v is minus 60 there. So it is 1 by u equals minus 1 by 20 plus 1 by 60. I think all of you can calculate from here onwards. It's all about simple LCMs and all, 20 and 60. You can directly take it as 60, so you get minus 3 plus 1. So is it visible? Right. So 1 by u is equals to minus 2 by 60. So I write it here, the remaining half. So it is looking like 1 by u equals minus 1 by 30, or you can say the object distance has to be minus 30 centimeters. My dear students, please mind in the calculations that we get the minus very naturally, and that minus indicates that the object is to be placed on the left hand side at a distance of 30 centimeters, which is exactly the case. If you look at the numbers, focal length was 20, radius is 40, image was forming at 60, that is beyond C, and we know everything about it from the ray diagrams. Make it sure you're perfect with your ray diagrams of both concave and convex mirrors. If you are not sure, please do watch the video. The link is provided above. So 20 centimeters, 40, 60 and everything like. Okay, so you get u is equal to minus 30, absolutely correct. So the object has to be somewhere here. Alright. So everything is clear. What else I need? Height of the image. So we have this formula. Also, h dash by h equals minus v by u. Very simple formula. I think everybody remembers that. So h dash equals minus v by u multiplied with h. So h dash should be equal to minus v. Where is the v value? Minus 60. U is minus 30 and h, height of the object, is 15. So I've neglected writing the units. You can see that the units will get cancelled for this too, but that extra centimeter lives on, and this minus is out, then 32, and you get answer is minus 30 centimeters. Now my dear students, again you need to understand this minus. What does it indicate? Does it have any relevance? Absolutely yes. It says this minus, height of the image minus, it says the image is formed below the principal axis. I am talking about the height, and that indicates an inverted image. It indicates an inverted image. Minus, u is minus 30, that is what we wanted. And finally you can easily say the nature. What is the nature of the image? Definitely real and inverted, and if you want to even talk about the size, as you guessed it, it has to be magnified. How many times magnified? That we can find out easily with the help of magnification. Right? So we can do that. Let me show you. Let me quickly rub off this portion and calculate magnification. So magnification m we could have done by any of the formulas. H dash by h, one of its very natural simple formulas there. H dash is minus 30 centimeters and h is plus 15 centimeters, and you can see that m equals minus 2. This is very, very important, very important. You can see magnification doesn't carry any units because the units are getting cancelled off, and you're left with a number with a sign. In this case the sign is minus, and this minus indicates a lot of things. This minus indicates the image is real and inverted and 2 times magnified. That is what you could easily see by your common sense. Height of the image obtained is 30 centimeters. Height of the actual object was 15 centimeters. So the image was naturally magnified 2 times. Hope I'm very clear in making you understand how to solve this problem, right? Do note it down and keep practicing, okay? We'll move on to the next question. Now moving on to the second question. The question is, an object is placed at a distance of 12 centimeters from a concave mirror. The image formed is real and 4 times larger than the object. So calculate the distance of the image from the mirror. That's it. The question is very clear. So let me help you how to solve such question. One good thing about this question is that it clearly mentions which mirror you need to deal with. The answer is concave mirror. Another very good clue is directly mentioned, that the image is real. So did not think about it. Alright. So you needed the mirror, you needed the nature of the image, clear. Object distance is given to you 12 centimeters. In this question you may not even prefer to draw a rough concave mirror also. If you remember the sign conventions, object distance always is negative in sign. We put a minus sign there. Alright. Okay. What it tells you is that the height of the image formed is 4 times the height of the object. So now you have to do the point that you need to calculate actually the image distance. You need to actually calculate the image distance. So using this clue, I can write h dash by h is equal to 4. That's all good. My dear students, please be careful with these problems. They are very easy, but they can be slightly tricky also with respect to the signs. H dash by h equals 4 is all good, but the question says it's a real image, so the sign here should be minus. That's it, very important. In a real image, h is always positive, that is the height of the object above principal axis. But a real image is also inverted, so h dash is formed below the principal axis, so the sign has to be negative. Negative by positive is negative. It's a very, very important point. Many students miss it out and hence the answers go wrong. So now if you observe, this is nothing but your magnification. So if you've understood from here onwards, you could have directly written what was the question talking about. The question was talking about its magnification. So it's m equals minus 4. So find out v. So we know m equals minus v by u. That's a formula. So m is known to us, u is known to us, and that now sounds very simple problem. U is minus 12, and you can see that we lose some signs, and hence v is equals to minus 48 centimeters. So the image is going to form to the left hand side of the pole of the mirror at a distance of 48 centimeters. It was easy and clear, I suppose. Please note it down. Now we move on to the third question. A concave mirror forms an image of 20 centimeter high object on a screen placed 5 meters away from the mirror. The height of the image is 50 centimeters. So find the focal length of the mirror and the distance between the mirror and the object. Alright. Again, the question I have chosen here is related with concave mirror. So let us solve it. Solution to question number 3. The question says the height of the object given for concave mirror. Students, I've just noted down the questions on the paper. That's it. So that I can solve it, because I can't see the questions clear otherwise. So height of the object is 20 centimeters, not a surprise, so it's positive there. The image is formed on a screen placed 5 meters away from the mirror. Please be careful. So that's image formed on the screen, so the image is real. So it's formed at a distance of 5 meters, so the sign has to be minus because the image is formed real, obtained on the screen. The height of the image, h dash, is given to us as 50 centimeters. Without forgetting the sign, it has to be an inverted image. Hope I'm clear there. So it has to be naturally a minus sign. So find the focal length of the mirror. You can do it faster now. Focal length and the distance between the mirror and the object. So it's also asking you object distance. Is that clear? Okay, good. So now we can definitely move on to find out anything. You know these three, so you can find. So now we can easily find out u, isn't it? Object distance using the formula h dash by h equals minus v by u. Always get your formula right. U goes up, so you'll find it is minus v into h by h dash. H by h dash. Is that clear? So u has to be minus V. V is given in meters. Please mind it. Don't forget to convert it into centimeters. So it has to be minus 500 centimeters into height of the object plus 20 centimeters. The height of the image, that is minus 50 centimeters. That's it. So we lose the zeros, and this is 5 goes 10. I even lose the signs. Do I lose the signs? Minus, or there was an extra minus there. Yeah. It's a minus. So minus and minus is out. Still I am left with the minus sign. So you'll find that it is 10 into 20. So that is going to be minus 200 centimeters, or you can directly say the object is standing at a location of 2 meters away from the mirror. 2 meters. Okay, good. And at the same time you asked me to find out the focal length. So we can do that with the help of mirror formula. 1 by V plus 1 by U equals 1 by F. So very easy from here onwards. You can directly go with meters also. The numbers will be much simpler. It's minus 5 plus minus 2 is 1 by F. So LCM is 10. My dear students, I'm doing in meters in this case. Whenever I need, I can just change upon. Minus 2 minus 5 is 1 by F. So you can easily see that we are going to get F equals minus 10 by 7 meters. Okay, minus 10 by 7 meters. You could have left it this way also. Or if you wanted to convert, definitely we can convert into 10 into 100 by 7 centimeters. Minus 1.42 meters, which is almost equivalent to 14.2 centimeters. Alright, hope I'm clear in this question. Please note it down. Thank you. Hope you are feeling good and making you comfortable in solving the problems. Alright, are you feeling good? Okay, let's move on. Keep practicing, not an issue at all. Keep practicing. Let us move on to question number 4. The question number 4 reads, a point source is 10 centimeters from a diverging mirror. Catch it up. And is then moved through 8 centimeters towards the mirror. How much does the image move if the radius of curvature of the mirror is 4.8 centimeters? Let's solve it. So solution to question number 4 will be something like this. You can even try by yourself. It's a very good question. Slightly moving higher up. This is your convex mirror. In the question it is mentioned as diverging mirror. So this is how it should look like in terms of a diagrammatic view. Objects are always on the left hand side. So it says that initially the object distance was 10 centimeters. The radius of curvature, the distance from P to C, is given as 4.8 centimeters. Alright? So if you are very thorough with convex mirrors behavior and the image formation, you should be feeling it easy. The image will be always forming between the pole and the focus. The image will never go out of the focus. Alright? Seems to be behind the mirror and virtual and erect line. So the first case says if U is equals to minus 10 centimeters and R is plus 4.8 centimeters, which means the focal length will be 2.4 centimeters. Clear? Then you can first of all find out where is the image going to form like, if this is the case 1. So you'll use the mirror formula, 1 by V plus 1 by U equals 1 by F. Put in your numbers correctly, 1 by F minus 1 by U. So you should find 1 by F is equals to, given to you, 2.4 centimeters minus U, this is equals to minus 10 centimeters. So this is going to be 10 by 24, I prefer to write, plus 1 by 10, just removing the decimal, I find it easier, right? That's a good way. So now we can move forward, and here we have 2 5s and 2 12s, you can do that. So let us quickly find out in the first original case where would the image form. So here you find the LCM is like 2 6 and 2 5s. 12 5 60. That's all good. 25 plus 6, 31 by 60. So the answer looks like 60 by 31 centimeters. I don't bother to convert that into decimals because that is not my actual target. All clear? Now the question says that this object is going to move. It is going to move towards the mirror by a distance of 8 centimeters. So it will be somewhere here, suppose, position 2. So how far is the object from the mirror? That's what is important. That is your U, find it, object distance. So this 8 is completely irrelevant to us. Originally it was 10, moved by 8 centimeters. So it is now only 2 centimeters away from the mirror. So object distance is going to be now 2 centimeters. So again, from the perfection of ray diagrams, you should be feeling it. As the object is getting closer to the mirror, the image is also shifting towards the mirror. It's getting more and more closer towards the mirror. Alright, so let us now quickly calculate that part. Okay? So I changed this portion, but I do note down this answer. The first case answer is 60 by 31 centimeters. Because the question is actually asking me what would be the shift in the image formation. So the next case, case 2, now you can write U prime is minus 2 centimeters. I hope I'm very clear with that too. Alright, and yeah, focal length is not changing, it's plus 2.4 centimeters. So 1 by V plus 1 by U equals 1 by F. So 1 by V should be equals to 1 by F minus 1 by U. Put in the numbers, and 1 by F is equals to 2.4 minus U, U prime suppose, and let us call it as V prime, yes. And this is going to be minus 2, alright. So 1 by V prime is equals to 10 by 24 plus 1 by 2. So 1 by V prime is equals to 2 5s and 2 12s. So we are going to get 5 by 12 plus 1 by 2. So let us do it there. Is that clear? Okay. So 1 by V prime should be equal to 12 2s is 24 is the LCM. 2 5s 10 there and 2 12s. Oh, everything is going clear. Okay. So V prime should be looking like 24 by 22. That is 12 by 11 centimeters. So the image distance is going to be now a shorter one. It is only 12 by 11 centimeters. Alright. So this is the second answer. This was the first answer. Then hence, we can rub off this portion, right? Find the shift in the image. Alright. Hence, the shift in the image will be, this was a larger distance, V, this is a bit shorter, V minus V prime. My dear students, nothing to bother about the sign conventions, okay? You need to only find the change in the shifting of the image. So V is 60 by 31 and that is 12 by 11. So you can go for the LCM, 31 into 11 over here. 11 into 60, 660 minus 31 into 12, quickly you can check it out, 2 1s, 2 3s, 1, 3, 3, 7, 2, if I'm not wrong there, yeah, absolutely. So we are left with 660 minus 372, that's gonna be 10 2s 8, 15 7s 8, 5 3s 2, and 11 1s 11, 11 3s 33, plus 1, 34. So the shift in the image is going to be 288 by 341 centimeters. Yeah, it's just slightly not comfortable numbers. If you just divide and check it out, the answer approximately comes out to be 0.85 centimeters. So the shift in the image will be around 0.85 centimeters. Hope I'm clear in this question, right? Note it down. Okay, dear students, let's move on to the last question of this video class, the fifth question. All right, you can pause it and always learn better. In my next video, we'll be doing some slightly challenging problems. All right, so first part of this video should be slightly easy and comfortable. Get going. Another question also I have to get for convex mirror. So question number 5 is, a convex mirror of focal length f produces an image 1/nth the size of the object. Calculate the distance of the object from the mirror in terms of this f and n. So this question sounds tricky for some of the students because there are no numbers to deal with. Okay, 1/nth the size of the object. Convex mirror, definitely it is going to form a diminished image. So not an issue at all. It's given for convex mirror. So we have to just deal with the alphabets here. The focal length is given to you plus f. All right. So height of the image is given to you as 1/nth the size of the object. This is what you need to translate from the question reading. So from there I see h dash by h equals 1/n. So this also means m equals 1/n. But I need to find out object distance in terms of f and n. So I will replace this equation m with its other formula, minus v by u equals 1/n. From here I find that v can be written as minus u by n. Is that clear? So we get v is minus u by n. So now we can find out from the mirror formula 1/v plus 1/u is equals 1/f. So 1/v minus u by n plus u equals 1/f, and here you find it is minus n by u plus 1/u equals 1/f. So it's going to be minus n plus 1/u equals 1/f. So u should be equal to f into 1 minus n. That's it, my dear students, for this class. Do practice these 5 questions perfectly. See you again in my next video with some more challenging problems. So keep studying well, stay safe, stay healthy. See you again. Alright? Thank you.